Hello friends, today we will discuss about Fajan'S rule. What is that? Fajan'S rule. Now what is this rule? This rule gives the covalent character in an ionic bond. Now you must be wondering what is covalent character in ionic bond. So for that, let me just tell you. Before that, you just know it's a qualitative estimation of covalent character in an ionic bond. I mean, you cannot say what particular percentage of covalent character is there in an ionic bond, like it's 20%, 30%. No, you cannot. You just compare between various molecules, various ionic compounds, and compare where the covalent character is more. Right? It's a qualitative, not quantitative. Right? Now let's go into the concept. For instance, let me take an ionic compound, that is sodium chloride. Now you know in sodium chloride there is a transfer of electron from sodium atom to chlorine atom, right? So as we have already discussed, sodium has electronic configuration of 281. Chlorine has electronic configuration of 287. Now what happens? Sodium loses one electron. Sodium loses one electron. Let me just show the Lewis symbol. This is sodium. This is chlorine. Now what happens? Sodium loses one electron to chlorine. As a result, it becomes Na plus, and this becomes Cl minus. Why Cl minus? It accepts one extra electron that came from sodium, right? Right. Now, what happens under the influence of the cation, right? That is sodium, Na plus, the electronic cloud of the chloride ion, that is slightly shifted towards Na plus, right? So remember, cation attracts the electronic cloud of chloride ion towards itself. So what can I write? So there is ionic bond between these two. There is a force of attraction, that is ionic bond. Now under the influence of the cation, that is Na plus, the electronic cloud of, this is the electronic cloud around chloride ion, that is shifted towards sodium, Na plus. Okay, this is known as polarization of the anion. What is the anion? Anion is chloride ion, Cl minus. So we call this polarization of anion. What do we call? Polarization of anion. What caused the anion to be polarized? That is Na plus. So the cation is said to be having polarizing power. So cation has polarizing power. Because it caused the polarization of the anion, so cation is said to be having the polarizing power. Now, as you know that for covalent bond formation, two atoms should come close to each other, then only overlapping can occur, or sharing of electron can occur, overlapping of atomic orbitals, then sharing of electron can occur. So when the anion comes closer to the cation, so what happens? The electronic clouds of both come closer to each other, and there is more chance for sharing of electron. I am not saying there is sharing of electron, I am saying that there is more tendency for the electrons to be shared, or the bond tend to be covalent. I am not saying the bond becomes covalent. I am saying the bond tends to be more covalent because both the spaces come very close to each other, right? Okay. So I can say that covalent character in ionic bond, it depends on the cation as well as the anion. More the polarizing power of the cation, more will be the distortion or shifting of the anion towards the cation, or the polarization of the anion. Okay, so anion is polarized, it means it's shifted towards the cation. Okay, so more the polarizing power of the cation, more will be the shifting or distortion or polarization of the anion towards the cation, right? So it basically depends on the polarizing power of the cation and polarizability of the anion, or the ability of the anion to be polarized. It depends on that also. So I can write it. Covalent character in ionic bond, it depends basically on polarizing power of cation and polarization of anion, or we also call it polarizability, the ability to be polarized. Polarizability. Okay, right. Now we will see the factors which determines the polarizing power of the cation and the polarizability of the anion. Now the factor number 1, charge. Now what do you think? If the cation has more charge or more positive charge, it will attract or polarize the anion more, right? Because electron cloud is basically negative. If the positive charge is more, then the electron cloud will be shifted more towards the anion. Okay, and there will be more tendency for electron sharing, or there will be more tendency for covalent bond. Okay, I can say that if charge is more of the cation, then the polarizing power of the cation is more. Factor number 1, charge more. Next, come to size of the cation. What do you think about the size? Now let me give you an example. There are two students who are shouting. In first case, they are shouting in a classroom, and in second case, they are shouting in a big playground. Where do you think the effectiveness of the sound or the loudness will be more? Obviously in a small classroom, right? In a big playground, the sound will be diffused, it will go into the atmosphere, right? So what I mean, if the classroom being the size of the cation and playground will be being the size of the cation, the classroom is smaller and the playground is bigger. Where do you think the effectiveness of the cation or the loudness of the sound is more? Obviously in the classroom. So if the student shouting being the cation and the classroom being the size, obviously if the size is smaller, then the effectiveness of the cation will be more, right? So if size is small. Okay, right. Again, there is another factor of cation. This is very important. That is pseudo noble gas configuration. Okay. Now what is pseudo noble gas configuration? Or I can PNGC. What does it mean? It means that pseudo means false. Generally, you know that noble gas has a configuration of NS2, NP6. These are noble gas. Noble gas atom has a configuration of NS2, NP6. Right. What is pseudo noble gas? If the configuration is, pseudo noble gas configuration means if the configuration is NS2, NP6, ND10. Now what is N? N is the outermost orbit or outermost shell. If the configuration is NS2, NP6, ND10, then that is pseudo noble gas configuration. For example, if you have copper Cu+. Okay. Now, do you remember the electronic configuration of copper? It was taught in atomic structure chapter, in which it's an exception. Copper has atomic number 29. So its configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d9. Four is 2, 3d9. Now, as you know, 1s, 2s, 2p, 3s, 3p, 4s, 3d. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 first, then 3d9. Now, as this was an exception, what happens here? Here, the 4 is, instead of being 2, it is 1. And 3d becomes 10. Instead of 2, 9, it becomes 1 and 10. Why is that? Because fully filled d orbital is stable, and d orbital can have maximum number of 10 electrons. So instead of 9, they have 10 electrons to be stable. Right? 4 is 1, 3d 10. Okay. Now, if I draw Cu+, copper+, so the electron will be removed from the outermost orbit. What is the outermost orbit here? 4th orbit. Although 4s is filled first with electron because it's having lower energy. You will know this in atomic structure. But while removing electron, you will remove an electron from 4s first, okay, because it's being the outermost orbit. So copper+ means 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So, if I arrange it according to orbit, what will I write? 1s2, 2s2, 2p6, 3 comes before 4, so I write 3s2, 3p6, and I bring this 3d here, 3d10, and 4s1. Okay, so this is ns2, np6, and it's not 4s1 anymore because one electron have been removed, so it's 4s0. Right? Again is 4s0. Instead of writing 4s0, I can remove it. Okay. Right? So, now it becomes a pseudo noble gas configuration. So, Cu+ has very high polarizing power. As I told, pseudo noble gas configuration has more polarizing power. Now, in periodic table, you can see copper 3. There are 3 elements which lie one below other. They are copper, silver, and gold. Cu, Ag, and Au. So, in periodic table, if you see copper, silver, and gold, they are in the same group. So the electronic configuration will also be same. So Cu plus Au plus Ag plus. They will also have the NS2 and P6 ND10 configuration. This was 3S2, 3P6, 3D10. This will be 4S2, 4P6, 4D10. This will be 5S2, 5P6, 5B10, 5D10, right? So all these three, they have pseudo inert gas configuration and they have high polarizing power. Again I write Zn2 plus. This you can make electronic configuration of Zn2 plus. This is also 3s2, 3p5, 3d10. So this is also pseudo inert gas configuration. Below zinc there were atoms or there were elements cadmium and mercury. So Cd2 plus and Hg2 plus. They are also having pseudo inert gas configuration. So they will also have very high polarizing power. So three factors of cation we came across. One was charge. More the charge, more will be the polarizing power. Smaller the size, more will be the polarizing power. Why? Because I gave the example of two boys, two students shouting being the cation and classroom being the size. Where the effectiveness or loudness is more, where the size is small, or in a small classroom. But if the same two boys, they shout in a playground, the effectiveness or loudness won't be that much because it will diffuse, right? So smaller the size, more will be the polarizing power. Again, if the cation has pseudo noble gas configuration, then also the polarizing power will be more. So these are regarding the cation. Now come to anion. Now as you can see, more the ability of anion to be polarized, more will be the polarization of the anion, right? Now remember, okay, let me give you two examples. This is one anion. This is another anion. The first one is the smaller and second one is the larger anion. Now, although it's an anion, the center should have a nucleus. That is, nucleus has positive charge. The center nucleus has positive charge. Now, if the size of the anion is more, so what happens? The nuclear effect on the outermost electronic cloud, or the bigger, in case of bigger anion, the effectiveness or the effect of nucleus won't be that much because it has to influence over a larger distance, right? So it's easy for the cation to polarize it or to attract towards itself, right? Because the nucleus doesn't have that much influence over the anion, the outer electronic cloud. So for the cation, it's quite easy to attract it or to polarize it. So the first factor is size of the anion, that is more, or I can write large. Larger the size, more will be the polarizability of the anion. What is the second factor? Charge. Again you think, if the charge of the anion, the negative charge is more, it will obviously attracted more towards the cation. So if charge is more, the polarization or the polarizability of the anion will be more. So to sum up, what can I write? For cation, charge more, size less, and pseudo noble gas configuration. For anion, size more, charge also more. So these are the 5 conditions. If present, then the covalent character in an ionic bond will be more, right? Now let us see some examples, right? For example, first we see the example of question number 1, LiCl, sodium chloride, potassium chloride, rubidium chloride. Now the question is, where is the covalent character more? Now here the anions are same, so you have to compare the cations. Now Li plus, Na plus, K plus, Rb plus. Now they are present in a group. Down the group, what happens to the size? Increases. So the smallest size being the lithium. So lithium, so the size, the order of the size is this, lithium is the smallest. So the polarizing power will be reversed. Here the charge is same. So smaller the size, more will be the polarizing power. So polarizing power of lithium will be the most, the polarizing power. This is the order of polarizing power. Okay. So as this is the polarizing power order, hence the covalent character will be obviously more in case of lithium. So the answer being, this is the covalent character. Now you're clear about this? Okay. Now let me write another question. Same question, same type, BeCl2, MgCl2. Where do you think what is the cation here? B2 plus, anion Cl minus. Here the cation is Mg2 plus, the anion is Cl minus. Anions are same, nothing to compare. The cation, the B2 plus, has a smaller size. They lie in a group, beryllium and magnesium, right? Hence the polarizing power of beryllium B2 plus will be more. Hence the covalent character will also be more. So this is the second example. Now let me take another question. If I write NaF, NaCl, NaBr, NaI. Now you tell, here the cations are same. Here the cation is Na plus. Everywhere the cations are Na plus. But the anions are F minus, Cl minus, Br minus, I minus. As they lie in a group, the anions, and the size of I minus being the largest one, so it will be polarized easily, so it will have more covalent character. So what is the order of covalent character? This is the order of covalent character. Covalent character. Right? You are clear up to this? Okay. Now remember, more the covalent character, less will be the solubility in water. You know this because in ionic compound we saw that ionic compounds are soluble in water, because ionic compounds, they are soluble in polar solvents, water being a polar solvent. Ionic compounds, they are soluble in water. It means they are not soluble in water. The covalent compounds are not soluble in water because covalents are non-polar. Water is a polar solvent. So covalent compounds are not soluble in water. So more the covalent character, less will be the solubility in water. Again, another character is, you saw in the ionic compounds only, the melting point, boiling point of ionic compounds are very high. Why? Because all the ions, they are attracted by the strong electrostatic or ionic force of attraction. So it's very difficult for them to convert from solid to liquid. They require more amount of heat or more temperature. So the melting point is very high. So therefore I can say that in covalent character, the melting point, boiling point will be less, because in ionic compound it was more. Covalent compound, the melting point, boiling point is less, because the force of attraction is not very high as compared to ionic compound in case of a covalent compound, right? So again remember, more is the covalent character of a compound, more will be its color intensity or its color imparting nature. Okay, it will be darker if the covalent character is more. Okay, so write a note. What is the note? Note is covalent character more. It implies solubility in water less, number 1. Number 2, melting point, boiling point less. Number 3, they will have color imparting means color giving, color imparting nature. I can write they are darker. So these are the 3 things associated with covalent character. Now based on these, let's do a few problems, few questions. Now suppose there is a question, BeCl2, beryllium chloride, and let me write the question again. Suppose there are 2 compounds, BF2 and MgF2, beryllium fluoride and magnesium fluoride. It is asked which is having more melting point, right? Now as you know, more the ionic character, more will the melting point, more the covalent character, less will be the melting point. We just saw this. So where do you think the covalent character is more? Here B2 plus, here Mg2 plus. Anions are same, so polarizing power will be more in case of B2 plus, because charge in both the cases are same, but size is lesser in beryllium 2 plus. So it will have more polarizing power. So it will have more, the compound will have more covalent character. So as beryllium fluoride has more covalent character, so it has less melting point. Okay, so this was the first question. Now similarly, I take another one. I take calcium chloride and calcium bromide. Now you tell, where is the covalent character more? Cations are same. We'll compare the anions. Here the anion is Cl minus, here the anion is Br minus. More the size, more will be the polarizability, more will be the covalent character. So as the size is more here, hence the covalent character is also more here. So which one having less melting point? Here calcium bromide will have less melting point because it's having more covalent character. Again, I take another example. Sodium chloride and cuprous chloride. You can see here the anions are same, Cl minus, but the cations are different. Here the cation is Na plus, here the cation is Cu plus. Now what do you think? Where the covalent character is more? As we have done, Cu plus has pseudo inert gas configuration or pseudo noble gas configuration. So it has more polarizing power. So it has more covalent character. So as it has more covalent character, so it has less melting point. Okay, right. Same can be said with solubility in water. All will have less solubility in water. Magnesium fluoride, calcium bromide, cuprous chloride, as compared to BeF2, CaCl2, NaCl respectively, they will have less solubility in water. Now, again, if I ask you another question regarding solubility, right? FeOH twice, ferrous hydroxide and ferric hydroxide. Where do you think the solubility will be more? In water. Now you see that here the anions are same, OH minus, but the cations are different. Here Fe2 plus, here Fe3 plus. Charge more Fe3 plus, size also less Fe3 plus. You know that more iron Fe, Fe2 plus, Fe3 plus, more the positive charge, the size decreases. We will see in periodicity chapter. For the time being, you just remember Fe3 plus has smaller size than Fe2 plus. Also the charge is more. So less size, more charge. So polarizing power is more. So the covalent character is more. So as this has more covalent character, so this is less soluble in water. Clear up to this? Right. Now, if you see another question, right, like if I take another example, same solubility, question 1, question 2, Ag2O and Ag2S. Again here the cations are same, Ag plus, the anions O2 minus, S2 minus. Sulfur comes below oxygen in a group, so the size of sulfur is more, so polarizability is more, so covalent character of Ag2S is more, so it's again less soluble because more covalent character. Here I am talking about covalent character. Covalent character. Here also it's greater than this in terms of covalent character. Okay. Now again, the last application, that was color imparting nature. You see that if I take 4 compounds like AgF, again this is a question, AgF, AgCl, AgBr and AgL, where the covalent character is more? Obviously in AgI, because the cations are same, Ag plus, Ag plus, Ag plus, Ag plus. The anions are different, F minus, Cl minus, Br minus, I minus, right? So the covalent character is like this. Covalent character. So more the covalent character, more will be the color imparting nature or more will be the darkness. So this is dark yellow. AgBr is yellow. AgCl is light yellow or lightish yellow, or it's more white, whitish yellow. And AgF is colorless, or it's like white, colorless. So we saw that more the covalent character, more will be the darkness or color imparting nature. So in this class we saw the Fajan'S rule, means which tells you the covalent character in ionic bond. We saw the factors, we saw its application. So this is all about Fajan'S rule. Thank you.